Geomorphology. Under geomorphology, the first thing we need to learn is about the origin and evolution of Earth. Then geological time scale, interior of the Earth. So what is in the inside the Earth? The types of rocks, Earth movements, continental drift theory, seafloor splitting, plate tectonics theory. These are endogenic forces, forces which are acting from the Earth, not on the Earth, is what we call as exogenic forces. Exogenetic forces. Endogenetic forces, the forces which are acting within the Earth, are endogenic forces. Under the endogenic forces, we are looking onto continental drift theory, seafloor spreading, plate tectonics theory, volcanism, geomagnetism, earthquakes, tsunami, exogenic movements, landforms. Now, what is geomorphology? Is the study of physical features. First, we have to look into the physical features, various landforms, mountains, plains, rivers. The major forces which are responsible for the features is under the earth. Endogenic forces are responsible for major features. Endogenetic forces are responsible for the major features which we look onto, like mountains, plains, rivers. Now, geomorphology is the study of physical features and the processes in which the features are formed. We have to study the physical features and processes which are responsible for these features. Physical features and processes. Geo means earth and morph means topography. Logy is a scientific study. The scientific study of topography of the earth and the processes. And we have certain processes through which these topography are created. Now, origin and evolution of the earth. We all know from the nebular hypothesis of Laplace, even we have the gaseous hypothesis of Immanuel Kant, right? When we are looking onto the nebular hypothesis of Laplace, the beginning is 4.5 billion years ago. The beginning of the universe is 13.7 billion years ago, whereas the beginning of the sun is 4.5 billion years ago. Now we have the sun, stellar wind, stellar radiation, wind, and magnetic field from the sun. We have earth. Due to these magnetic winds, there was a loss of the primary atmosphere, formation of protoplanetary disk migration. Now, cooling and differentiation is taking place. The cooling leads to the settlement of the heavier atoms, heavier elements at the core, and lighter elements at the top. Now, plate tectonics. After that, we have the secondary atmosphere and life on Earth. The various activities which are interior on the Earth are: first, it is a hot and volatile fireball. Then density separation. So first it is hot and then we say it as a volatile. Hot and volatile fire, it was like a fireball. Then we had density separation. Right. It got separated due to density. So density separation. Condensation, reduction in the size due to reduction in the temperature. Differentiation into different layers like core, mantle, right? Crust. Differentiation. Now, what is happening at the Earth's atmosphere? In the interior, first it was hot and volatile. It started density separation, condensation, differentiation. Once it starts condensing, it starts differentiation, right? So we go for it is a hot ball. It starts density first starts to separate. Density first starts to separate, right? After the density separation we do have condensation. So after the density separation is when we have the condensation, and after condensation we go for the differentiation into the layers. So density, it starts condensing to different layers. Now, the Earth's atmosphere. Earth's atmosphere primarily which consists of hydrogen and helium at the Earth's atmosphere, but it was removed due to the solar wind. first we saw about the interior. Next we are looking onto the Earth's atmosphere. So now when we look into the Earth's atmosphere, it primarily consists of hydrogen and helium, which was taken away by solar wind. So this was taken away by winds. Now degassing. Due to density separation, condensation, differentiation, the gases which are present on the earth, the interior gases starts moving to the surface. So first the primary atmosphere was taken away, and degassing is the gases which are at the interior of the earth. So the interior of the earth had gases. These gases came to the surface. The interior of the earth had gases, and these gases came to the surface. Now, volcanic eruptions took place. After degassing, it was volcanic eruptions where CO2 and water vapor came into. Condensation of water vapor reduces CO2 and formation of the ocean. So, first degassing all the gases which came away, but it was lacking water vapor. Now, how do we get water vapor? The water vapor is through volcanic eruptions. So volcanic eruptions led to water vapor. Once volcanic eruptions was over, due to the water vapor, CO2 concentration got reduced, and we had long precipitations which led to the formation of oceans. Formation of the oceans filling up the depressions happened in 800 million years ago, and blue green algae, sorry, the rain took place for 800 million years. Blue green algae is approximately 3500 to 2800 years ago. Now, because of the blue green algae, we had flooding of the atmosphere with oxygen. It is because of this algae we are having flooding with the oxygen. So the first thing which happened is Earth's early atmosphere was taken away due to solar winds. The early atmosphere had hydrogen and helium. Hydrogen and helium were taken away in the early atmosphere, and the gases from the interior of the earth comes to the surface through degassing. Volcanic eruption led to increased concentration of CO2 and water vapor. Due to condensation of this water vapor, it reduced CO2 and it led to the formation of the oceans. Now here it filled up the depression. It rained for approximately 800 million years. Now blue-green algae approximately 3500 to 2800 million years ago, it caused flooding of the atmosphere with the oxygen. Now we look into the Earth's interior. 4800 million years ago, the Earth was hot and volatile. So it is 4.8 billion years ago. The Earth was a hot and volatile molten mass of ball of mass. It started cool down. The temperature was decreasing. Density separation, material segregation as per the density. Condensation reduces in the size. Differentiation is material segregation, crust, mantle, and in the core. Evolution of the Earth's atmosphere. This is evolution of the Earth's interior. Now, how did the atmosphere got evolved? The early atmosphere of the Earth is very thin gases surrounding it like hydrogen and helium. Primordial atmosphere. We had it as the primordial atmosphere. Now, this primordial atmosphere is stripped away from the Earth by solar wind. Presently, we have the atmosphere up to 64,000 kilometers. Degassing is the early Earth, the volatile mass, everything was mixed up, right? It started cooling down, density separation, and heavier materials sink and lighter materials swap. Gases were released and started to concentrate around the Earth's atmosphere. Because of volcanic eruption, magma is a mixture of solid, liquid, and in the gas. Therefore, due to volcanic eruption, there was increased concentration of CO2. The Earth's interior temperature increased. high temperature, high heat, molten material erupt outside and huge lava. Continuous volcanic eruption led to release of large amount of CO2, N2, nitrogen, water vapor, methane, and very little amount of the oxygen. But here the condensation of the water vapor. The water vapor starts to cool down. Water vapor is H2O, but oxygen is O2. Oxygen was not present until the blue green algae which flooded the atmosphere with oxygen. H2O is having the temperature is reduced. CO2 content also got dissolved in the water and it got dissolved into the seas. When rain falls passing through the atmosphere, it brings down CO2 in the atmosphere. So the rainfalls which are passing through the atmosphere brings down the CO2 in the atmosphere. Overall, the temperature has reduced. More rainfall, temperature has reduced, CO2 content reduced. Again, the temperature is reduced, therefore we had rainfall. This had taking place for 800 million years. Filled the depressions were due to meteorites and asteroids, huge craters and depressions which were created. And these depressions were filled with water due to the condensation of water vapor. Formation of the ocean. How did oxygen percentage increase? This was due to the blue-green algae photosynthesis and it released the oxygen. It was 3,500 to 2,800 million years ago. It was primitive unicellular and it is responsible for oxygen. Flooding of the atmosphere was greater than 21 percentage of oxygen 2,000 years ago. The changes in the Earth's atmosphere. Components. Life originated on the surface of the Earth 400 million years ago. Origin and evolution of the Earth. We have the nebular hypothesis is by Laplace. Earth originated as a part of the nebula which formed the solar system. Evolution. The planet initially was a hot, molten, volatile object 4800 million years ago. Due to the gradual increase in the density, the process of density separation started, causing heavy materials to sink towards the center of the earth and lighter materials towards the surface. This is what we call density separation. Condensation. With the time, the earth cooled further and gradually condensed into a smaller size. Differentiation is with further cooling led to the separation of different layers in the Earth's interior. Now, evolution of the atmosphere is the early atmosphere had a very thin atmosphere of hydrogen and helium, which was called as primordial atmosphere, was stripped off due to solar winds. So we say that the primordial atmosphere, there was a presence of primordial atmosphere, and this atmosphere was stripped off, right? This atmosphere was stripped off, and this was due to solar winds. Now, what is degassing? Degassing is the during the cooling of the earth, the gases and the water vapor were released from the earth's interior. The process through which these gases outpoured into the atmosphere is called as degassing. Volcanic eruptions. The higher temperature of the Earth's interior resulted in the volcanic eruptions on the surface, which released more gases in the atmosphere. The important gases are carbon dioxide, nitrogen, and water vapor, methane, very little amount of oxygen. Now, the condensation of the water vapor. As the Earth cooled, the water vapor started to condense, and CO2 in the atmosphere dissolved in the rainwater, and the temperature further decreased, which led to more condensation and more precipitation. The formation of the oceans. The rainfall brought huge quantity of water to the surface, which got collected in the depressions on the Earth's surface, forming oceans around 4 billion years ago. Blue-green algae. During the period between 3,500 to 2,500 million years ago, blue-green algae emerged in the ocean waters, which started to release ocean oxygen through the photosynthesis, flooding of atmosphere with the oxygen. By 2000 million years ago, the oceans were saturated with oxygen and oxygen started flooding the atmosphere, changing the composition of the atmosphere and creating conditions which were favorable for the emergence of the life. That's it.